Hello, everyone. Welcome to the RoboCup Junior Simulation Demonstration Competition. We will be our host for today. My name is Kai.
My name is Andy.
Nice to meet you. And first, we will start with our introduction. Having a little bit of a difficulty. So right. Next up, we're going to have a mini video explaining the rules for this competition and how all the simulation will be run.
We will now explain the rules of the competition for you to better understand and enjoy the runs. This is how the field looks like. The green box is the start tile, and the robot will be placed here initially. The silver tiles are used as a checkpoint. When the robot gets stuck somewhere or a lack of progress happens, it will be placed back to the most recent checkpoint, and the run will continue on from there. The robot must traverse this maze to find as many victims as possible within a time limit of 8 minutes. There are two types of victims, heated and visual victims. The visual victims are subdivided into H, S, U, which stands for harmed, stable, and unharmed. The robot uses its temperature sensor and the camera to detect these victims in the field. If it can identify which type of victim it has detected, additional points will be awarded. The points for each victim depends on whether the victim is placed on a linear wall or a floating wall. Linear walls can be reached from the start by strictly following the left or right hand side of the wall adjacent to the robot. 10 points are awarded for detecting victims on linear walls. Floating walls cannot be reached simply by following the left or rightmost wall from the start tile. To systematically detect all victims on a floating wall, robots must have some mapping and navigation algorithms. 30 points are awarded to detecting victims on a floating wall. This is significantly higher than that of the linear wall because of its difficulty. Finally, there are other hazards for the robot to overcome, such as swamps, holes, and obstacles. A robot can go through a swamp, but its speed can be reduced by a third. Robots must avoid holes or else it will fall into them, causing a lack of progress and penalties on the score. Swamps and holes can be detected using a light sensor underneath the robot. Obstacles are placed to block the path of robots navigating around the maze.
All right. Now Andy will explain the schedule for this competition. All right, sorry, the schedule apparently wasn't recorded. And Andy, could you explain the schedule again?
So for the schedule, I'll go back on it again. So as you can see, the first half, we have about 10 teams on the first two blocks. So after opening ceremonies, we'll jump right into the simulation, starting with the defenders. And so, like I said before, there are two blocks, each with 4 or 5 teams. After each block, we'll have a Q&A session where we'll essentially just have a conversation, asking them about the systems and robots they used. And after these two blocks at 13:30 or 1:30, we'll have a coffee break. So for the second half of the schedule, again, we have the same 2-block system. And so we'll first start off with Jano Team Ita Salta, Argentina. And after the 2 blocks, we'll go into a coffee break at 3 o'clock or 15 o'clock. And we'll have an award ceremony right after that.
All right, apologies for the slight technical issue. So regarding Q&A sessions, hopefully an email has gone to all the teams with a Zoom link to join our conversation here. So after each block, we're going to invite all the team captains to come to a Zoom call with us to have a little bit of a chat about the run and the robot. If you haven't received an invitation, then please look at your submission portal, and you should find the link to this Zoom.
So next, I'll discuss the layout of the competition field. So as you can see, this is our competition field, and there are about 4 main blocks. So as you can see, the first one is generally normal, while the second one has some obstacles to block a robot's path. The third one has 4 black holes, so teams better watch and try not to fall out. And then the last one has a swamp. In total, there are about 12 victims, 5 heated, and a 7 visual. There are 2 obstacles, 1 swamp, 3 checkpoints, and 4 black holes, which comes to a total score of 340.
We hope to see how teams will do with this competition field, and we'll get right into the teams starting now. First up, we have defenders. Let's see their introduction video.
Hello, we are the Defenders team from Colégio Objetivo, São Paulo, Brazil. We decided to participate in this competition due to the similarity with the RoboCupJunior Rescue Maze modality, which we participated in the last 2 editions of LARC, the Latin American Robotics Competition. For this project, we adapted resources designed for the physical robot, converting part of the C++ software used in Arduino to Python, thus improving the functionality in the simulator. We also have improved the victim detection processing, based on improvements in camera image filtering, focusing on better performance in this international competition.
3, 2, 1, go!
Yeah, and we start.
Here we go. Let's see how the robot is doing. It seems to be going pretty well in the beginning right now. The robot has first detected the victim and gained 20 points. So one of the key points right there was the victim was able to correctly detect the victim, but also correctly identify the victim.
Seems it also got a heat victim, which is great. That's another 20 points. And so the robot is continuing on its path. It almost seems to be following the left-hand side of the wall.
It is. I think it is doing that. Oh, it skipped that part. We'll see if that was a planned method for the robot or not.
It did seem like. Seems like the robot just continued on its way.
It seems to be also doing like a depth search. So when the robot is navigating through the maze, it looks at a node where it has different branches, and it will try to go through all of them. But at the moment, the robot seems to be a bit stuck with the obstacle. Oh, a lack of progress has been made.
Uh-oh, it seems slightly confused. We might see another lack of progress here.
Yes, the robot is unfortunately stuck in the wall at the moment. We'll see if we can recover from this position. It's interesting to see teams who have participated in Rescue Maze and oh.
Uh-oh. Seems that
see.
it terminated due to a error. So
Unfortunately, that was the outcome for the simulation run for the team defenders. But we have to keep going. So we have the next team.
So the next team we have up is S-Bots.
Hi, we are Pascal, Janne and Philipp from Germany. We've actually competed in the real Rescue Maze competition before, and here you can see a clip of our robot in the real maze. We are actually using a fairly similar algorithm in this simulation today. Wish us luck and have a great competition.
Right. 3, 2, 1.
1, go.
Go. So S-Box, here we go. So they're another former, or let's say a current Rescue Maze participant. And it seems like the robot is also navigating the world quite well. Right now, following the right-hand side of the wall.
Yeah,
so slightly different.
Definitely has great turns and seems very accurate at the moment. Oh, it seems like it unfortunately missed a letter.
We'll see if we can find a subsequent visual victim. Once again, I think the know-how and experience from participating in Rescue Maze is being helpful for this competition as well.
Yeah,
the robot is doing well. It's going out of the first room almost, and oh, something has happened. So it's doing a couple of misidentification of victims. So essentially, the robot is sending to the controller that it has detected a victim, although there is no victim in sight, which gives a -5 point. And the robot seems to be now a little bit stuck again. We'll see if we can...
Stuck in a corner right here.
Okay. Time is ticking. The way this the programs were run was all the teams have submitted their code, and a couple of us got their program and followed the instructions for setting up their program environments and try to get the robot to run on this course. And although in a real competition, the team captain could call the lack of progress, in this competition, we decided to limit the number of lack of progresses as much as possible to keep all the teams in a fair ground. But that also means the robot must have a very robust program to work in the first go.
Unfortunately, it doesn't seem...
Fortunately,
yeah.
Yes, it seems to be in a bit of a loop right now, and time is running out. Okay, that was Team S-Bots. It scored some points, but the lack of progresses and the misidentification got them in the end, unfortunately.
Great job, though.
Right. Let's go to the next team. Next up, we have T-Project.
Greetings. We are one of the teams from Argentina, and this is our introductory video. I'm Ramiro from the southernmost city of the world.
I'm Santiago.
I'm Federico.
And Mas.
I am Matias, and the silent one is Juan, our mentor. We are from Buenos Aires.
We assembled the team and began working by the end of August as a part of a virtual workshop created by the Science Museum in our country.
This is the first time we work on Python and over a simulator. We usually work over Arduino and material robots. Therefore, this is a whole new challenge for us.
We divided ourselves in two main groups. One worked on a victim detection system with OpenCV, while the other focused on navigation and the detection of swamps and pits.
We think we still have a lot of work left to do and improvements to make for the next competition. Here in Argentina, we still have the RoboCup Juniors event in December, so we still have challenges to face.
Once again, thanks for the invitation, and we wish the best of luck for the remaining of the team.
Bye.
Good
Bye.
luck.
We see you there.
Bye.
3,
2,
2, 1,
1,
go!
go! Robot started moving. It's a much more unique movement than the other two, as it
Yeah.
seems. The robot is a kind of
It's like following the
moving
right.
in a very circular path.
Definitely interesting. But following the right side of the wall also means that it won't be able to get to the floating tiles as easy. So we'll see what systems it has in place to deal with that.
Yes, but at the moment it's doing pretty well. It's gone to the second quarter of the rescue field.
So far, our team is doing very well, actually.
Yes, it's already gone to the third floor, third room, and this room is quite interesting. It doesn't have any walls. It only has 4 black tiles or holes, and the robot must avoid it. So unlike
I'm sorry.
Sorry. Unlike the other rooms, robot must, especially for this kind of algorithm where it constantly checks the side of the robot, it needs to see if the black color is on the bottom constantly. The robot is doing some interesting movements here, almost falling down, but not exactly, and then it's managed to avoid all the holes, which is great.
Yeah.
It's finally gone into the final room.
It's crossing the swamp. It seems to be A-okay. So far, I think we see a heated victim, and so far it's doing great with a score of 120. That might be a letter victim. Yes, it is. So we're back onto the holes. We'll see.
Back onto the whole room, yes. It's doing really good. It's scoring 140 points at the moment.
Yeah,
We'll see how far it can get. So on the room the robot was just in, there are some floating tiles, and floating tiles means if the robot is following the right-hand side or left-hand side of the wall, just as this one is doing, it will not be able to reach it. So there needs to be some other algorithm in place to identify these rooms and identify these tiles to reach them in the end.
Especially for the floating tiles, the victims there are worth about 30 points, so they can definitely improve your score. Seems to be doing really good.
Yeah, it's back in the second room. It seems to be going good. Let's see if you can get this visual victim. Oh, it missed it, unfortunately, but it managed to go in the checkpoint. That's another 10 points. Bump it up to 190 points. And just on its path, we have a heated victim. So hopefully the robot can detect this as well.
Nice.
Good, that's good. It's 210 points.
So it's almost
Very
approaching
well.
the exit here, and we'll see if it goes back for that floating room.
If robot calls exit at the start tile, then the game ends and it will receive an exit bonus. And it does. So this was team T project. a score of 241 and a game time of 4 minutes 08. Congratulations, that was fantastic.
Amazing job. So we'll go on right to the next participant of the competition.
Yes.
So this team is the Flame.
Hi, I'm Brian Gann. My partner is Daraj, and he's not here to make this video, so I guess it's just me. Our team name is the Flame, and yeah.
All right, here we go. So this is the first team that is using C++ to run the robot, as opposed to other teams which is using Python. So it's an interesting choice. We'll see why this team made the choice as well. But it seems to be having a good start with the maze and tackling it quite well. Oh, it has missed the visual victim right there.
Yeah.
We'll see if we can get the heated victim. That's right ahead.
Definitely seems to be having more of a cautious turn. It's going a bit slower.
Yes.
So hopefully that will improve its accuracy. And it got a heated victim.
It got a heated victim. That's good. That's good. That's a good start. Yes, it seems to be the robot seems to be going following the left wall, but we'll see if that's the case or if there's another layer of maze navigation, so it actually reaches floating tiles. But so far, it seems like it's following the left wall.
Totally agree.
Oh, maybe not. It could be a version of depth search, where it looks at every node and goes through all the adjacent paths until it hits a dead end and comes back to that node and explores the maze in a very systematic method. So we'll see if the robot can actually reach all of the floating tiles.
So far, it seems to be doing great, though. I mean,
doing great. It's going in the third room.
And let's see if it can tackle the holes.
Yes. Yeah, that's a good start. I guess one important key feature of this competition, as opposed to the rescue maze competition, is there's a GPS equipped with the robot. So the robot has a global localization method, so it knows where it is, which is very helpful if the robot gets stuck or if the robot goes in circles in places, and it can go back to the original track. But we'll see how teams have used this system well in their algorithms. At the moment, the robot is almost navigating out of the third so-called room of the rescue field.
Also, another important thing to mention, it seems like the robot is detecting them right, but it's not giving back the type of victim. So that halves points to about 10.
Yes.
It might reach a checkpoint here.
Almost there. So it reaches checkpoint.
10 points.
On the right-hand side, there's a swamp. The robot has managed to avoid the swamp. You don't get a lack of progress, but the robot slows down significantly in the swamp.
And I think it's safe to assume that this team does not do any layer detection. But unless we see that in the future,
at the moment it hasn't been doing that.
Heated victims.
But it's doing a great job at maze navigation. It's managed to go to the final section of this and even go through the floating walls. So their maze navigation is solid, it seems.
Yeah, definitely. Seems it's going to the floating wall.
Oh.
It might be slightly stuck.
Is it stuck? I thought it was doing the victim detection, but yes, you're right. It seems to be a little bit stuck, unfortunately. There could be a lack of progress to the checkpoint. Luckily, oh, there we go. Luckily, the checkpoint is quite near. It wasn't far away. But something.
Slight confusion.
Something has happened. Not exactly sure what's going on, but the robot is a bit confused about where it's going and its navigation.
Yeah, it seems to be almost on a diagonal curve.
We'll see if it can recover from this this position, or if it has to go through another lack of progress.
I mean, luckily, it hasn't got stuck in any corners.
Exactly. It's getting there. It's going through the maze. Slowly but surely. A point to note with this competition compared to the rules of the competition is that the robot does not need to blink the LED for some time for victim detection, just because of how the once again there was an error with the program, or there was a bug with the running the program. So unfortunately, the game ends, and the Flame sees a score of 75 points.
Had great navigation, though, so props to them on that.
All right. Congratulations for the 4 teams that just went. This is the first Q&A session of this block. Do we have teams from Defenders, S-Bots, T-Project, and the Flame to join the Zoom channel?
It seems like we got S-Bots.
We got S-Bots. We'll see. Oh, we got T-Project as well.
Very nice.
That's very good. That's very good to see them. And then do we have the other ones? We have
Defenders.
Defenders, yes. That's 4 of them, 3 of them. And do we have Flames? Well, let's go with Defenders first. Hello, Defenders. Can you hear us?
Hello.
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 How did you find the simulation versus real life in Rescue Maze?
I think it was very different from real life, of course. It was a really great time we had here, and this was a totally new experience for us.
That's very good. I remember your team from the presentation event as well. You mentioned you moved your code from C++ to Python from Arduino, I guess. But how was that? Was that a difficult process, or was it quite straightforward moving on to different programming platforms?
Sometimes it was very difficult, but we managed to achieve our goal and transfer the code from Arduino that used to Python, and the code that we used in the Raspberry Pi. It was already made in Python, so
yes,
it was a little easier.
Right, I see. Okay. Do you have any questions to other teams that went, or to us?
I think to the. I think I don't have questions.
Okay. All right. We can get back to you later, but let's go through the other teams as well. So S-Bots.
So S-Bots. So we have a couple questions. So what do you think exactly happened in the run? We saw something unexpected occur.
Hello. Can you hear us?
Yes.
Yeah.
We can hear you.
Yeah. Okay. Yeah. So I think we know the issue already. It was kind of because we were relying on the GPS values, and as soon as the robot got teleported to the starting point, he was confused and was trying to get to the other point. Yeah, but I guess that happens if you rely on these GPS stuff.
So you said you relied on GPS. What exact algorithm did you use for the maze? Or like, how did you navigate it?
We used A-star, but as you can see, it turned out a bit difficult.
Yeah, it happens to a
That
lot
happens.
of times. So you also mentioned that you participated in maze before. So how did you find the simulation versus the real life experience?
It was kind of cool, and we want to thank you for doing this competition, first of all. It was kind of a nice experience. And I mean, you had some positive and negative aspects. You could really rely on like very clear values, but also ignore hardware problems. But yeah.
Yeah.
Thank you for participating in this competition too.
Cool. Yes.
So,
Yeah. Thanks.
did you have
Glad to
any
hear
teams
that.
for any of us, or questions for any of us?
No, I think we want to wish luck to all the future teams.
All right. Okay. So next up we have key project.
Hello.
Can you hear us?
I can hear you.
Okay. Okay, that's good. Hello. How did you find your run? Was it expected? Was it? Did you have more things?
We were expecting good results, but
yeah.
I think the map was benefited us a lot. I mean, we had an algorithm that kind of ignored the whole floating walls.
Yes.
But that obstacle there made us the whole run, where we recorded the center part. Also, we had a lot of problem with the pits. It kind of glitched and flied away many times. But we pulled through. And
yes, you got a good run. You went all the way through the maze and came all the way back. Was it a strategic choice to leave out the floating tiles to increase like simplicity and robustness of the robot?
We were planning to, once we came back to the beginning, instead of saying leave the first time, we will change the running algorithm and try some random movement.
Right.
But I believe we did safely, because if it was a risk, and 10% of points was a lot of points.
Yeah. Final question. How did you go about with your visual victim detection?
It was a mess. We split the job within the team members, and until the last day we had a very problematic system detection. It 2 times out of 3 it missed the point. It said it was anything but a letter, but in the end, just a few hours before we submitted the code, the member who had to do the letter recognition submitted their part correctly, and you can see it wasn't very well implemented, since we ignored a few letters, I believe 3 of them, but it went okay. We only recognized the first line of pixels, the first column.
Right.
And pulling out of that, we recognized all of the victims. You know what I mean?
Sorry, can you explain what you meant there with I guess you used OpenCV for the detection.
Exactly. We took a picture of the letter, and just by looking at the first column of pixels, we figured the first column. We figured out whether if it was all black pixels, it was an H. If it had white, black, white, black, white again, it was an S. And if it was all black up until the end where it was white, it was a new. You know what I mean?
Yeah, definitely.
Well, it was problematic in the end, but it worked, so I cannot complain.
I feel like all teams can definitely relate to working very late until the very last emission time. So great job. And so
But I'm very happy
yeah.
with the team we put through.
Yeah, it seems like you did very great. So the next team we have up is the Flame. So if you could come off mute.
Yeah, hello.
Hello. So we have some questions for you too. So was there any reason why you decided to go with C++?
Just more familiar with it, I guess. That's about it.
And also, what was that pathfinding algorithm you used? It seemed like it was very successful throughout the.
Yeah, we used BFS. Breath first search.
Breath first search?
I don't know what happened at the end though.
Oh, unfortunate. Yeah, I feel like it can always be especially unexpected, especially like for reasons of crashing. Like it definitely happens in every competition. So could you explain breadth first search and how you implemented that?
Well, it's basically like you like separate the whole thing into like tiles, and then each time you run breadth first search, it looks for the closest tile that you haven't visited yet. So most of the time it's like just one to either side, but if you're like surrounded by tiles that you've already visited, it'll like find the closest one that you haven't visited until you've gone through the whole maze, and then it'll go back to the start.
So it's like it's almost the opposite of depth search, or it seems
Yeah.
Instead of like going down one route exactly and actually finding the end of it, you go through each node that's on a corresponding level.
Yeah.
So have you ever participated in any other competition besides this, or is this the first one you've been in?
I did wine last year,
Wine.
but with COVID, it was kind of not really didn't happen. So
yeah, unfortunately, COVID had to change a lot of our CG's plans, but we can have competitions like these, so it's great that we're able to do this. And so, do you have any questions for us or for any of the other team members? Would you like to say anything?
No, not really.
No. Anyway, so thank you, and it seems like we have just finished our Q&A section.
Thank you.
Okay, sorry. There was a network issue and I got cut off, but now I'm back. Sorry, while I was left off from the live event, this question might have been there, but how did we have, because we have a little bit of time until the next block, how did everyone manage to collaborate in this situation? Did everyone work online, or what? Did people just happen to live close to each other, or what was the how did everyone manage this? Maybe from defenders.
Hi. So we used we used many remote control programs like TeamViewer. We used them GitHub too to manage repositories, and we used Discord. We used Discord so much during this time, and it was basically this.
Right, I see. Spots, how was this experience for you?
We used GitHub, and I think it was a nice reason to learn GitHub and Git, like version control.
Yeah.
And yeah, but we were able to meet in person in school, so we used that time a lot.
Yeah, that's always good. How about the project from Argentina?
Hello.
Hello?
What's the question? Sorry.
The question was, how did you manage to work together with your teammates under lockdown, or difficult to meet in person? Like, how did it work?
We never actually met. We
really
worked. One of our members even is from the southernmost city of the world, as he said. He's from Ushuaia, and we actually never met in real life with him, and we only met because of the lockdown. And it was great to get to meet him.
Interesting.
So, in a way, our team only exists because of the quarantine.
I see. No, that's good to hear. Everyone's having some ways of navigating around this. How about the flame? How did you?
I don't think the flame is here right now, but
oh, I see. Oh, never mind then. All right. Well, we're a little bit early on time, 5 minutes. But
it seems the flame has come back.
Oh, it's come back. Oh, amazing.
Yeah, I'm here. Sorry.
No worries. So the question was, how did you manage to cooperate with your teammates or with your mentors or whoever to get your program up and running and make progress in the competition?
Yeah, so we just used Discord primarily to talk to each other, and then we shared code on like Google Drive. Yeah, that's pretty much what we did.
I see. But you never really met in person, or?
No.
I see. And I guess a simulation
we weren't
competition.
like a team before this whole thing, so yeah.
Right. Okay, that makes sense. Yeah, it's I guess it's a little bit easier to do in simulation competition rather than a real world competition, because with hardware, it's difficult to transport the robot back and forth and get people to work on it, because you can't really share a hardware project that easily. But that's one of the great things about simulation competition. All right. Yeah, well, thank you to the 4 teams, Defenders, S-Bots, T-Project, and The Flame for spending your time and coming up for the Q&A session. So once we finish this session, we will go straight into the second block. All right. So we will call an end for the simulation, so the Q&A, and go to block 2 to see how the 5 teams, Friends, Orca Robotics, Nisshin, Yasui, Apples, and Tux 2 did on their runs.
So for the next team up, we have Friends.
I'm Chris Koo.
I'm Siddharth Srivastava.
And we're Team Friends. So we use Python, and for navigation, we use a virtual map plus BFS to navigate. We also use File.io to store our wall data and our victim data. We use for our visual victims, we use NumPy, OpenCV, and Tesseract. Thanks for watching, and please enjoy our run.
All right, here we go.
Let's go.
Okay, the robot is doing a very smooth kind of movement with the 90 degrees and even going straight over the tiles.
Seems to be doing something interesting, like it's almost tilting its head to the left.
I think the tilting could be for finding the victims, maybe. Like if you go in front of the wall, and then if there's a victim, it's going to see if there's a visual victim in front of it. But so far, it's managed to find a heated victim and correctly identify it.
It's doing a very nice job. It seems very, very smooth.
The smoothness, I think it's some kind of PID control on the 90 degrees turns and the movement on the wall. You can see it's accelerating and decelerating very smoothly.
Oh, and it got a letter victim.
Yeah, so it's doing, and it's also identified it correctly. We'll see if it identifies the other visual victims correctly as well.
I feel like
It's definitely moving cautiously, but navigating the maze quite well.
definitely that head tilting maybe or could be useful, especially in those tight corner letter detection scenarios.
Yes. So we'll see if they identify this correctly as well. And yes, they did. So it seems like this team, friends, have some algorithm in place to distinguish between H, S, and U for the visual victims.
So far, they're doing very nicely. I don't think they missed a single heat, visual, or checkpoint up to this point.
Yes. And I haven't been paying closely to the maze navigation, but at the moment it seems like they're going on the right side. And we'll see if they can handle this obstacle well. This obstacle is slightly annoying for robots because it's in the middle of the tile, and the robot could go halfway into the tile and then realize its movements are being hindered by the obstacle. So it needs to be able to identify that it is a obstacle and not a wall, but I think a lack of progress was called. So it's going back to the checkpoint, and we'll see if it can. Oh,
the robot seems slightly confused.
Something is happening.
Definitely, after lack of progress, a lot of teams do end up losing where they are.
Yes, this is interesting. Maybe it's what the team from SBots explained about how they're using the GPS coordinates, but once you move back, it kind of jumps all of a sudden and makes the algorithm a little bit corrupt, or there's some bug in the algorithm.
Yeah.
But the robot seems to be recovered, although it's going back to the start tile rather than exploring the rest of the maze, which is interesting choice. Yeah, it's
may reach the beginning.
Yes, they're going back, and maybe they'll have an exit. Yes. Well, congratulations for completing the run. That was Team Friends with a score of 103 points and a game time of 3 minutes and 52 seconds.
Nice job.
Good job. All right. We have the next team up. And the next team is going to be Orca Robotics. All right.
And
Here
we're
we
off.
go. Let's see if they do. They got some interesting maze navigation system in the introduction video. We can. Oh,
It might be a misidentification.
it is a misidentification. Oh, there's another misidentification. That's not fun probably, but we'll see how the robot is. Will keep going from this point.
Luckily, their score is 0, and the score can never go below 0, so not losing anything right now.
Yes. But it has to move out at this first section, and hopefully it will but at the moment it seems to be a bit stuck with misidentifications and kind of moving back and forth in this section.
Yeah. Unfortunately, it seems to be going back and forth from the start tile to the end of the compartment.
We'll see. Maybe a lack of progress can get the robot out of the situation, or or maybe we'll find out the way on its own. But we cannot do much other than hope for the robot. Oh, right. So that's being sped up at the moment because it's doing a similar kind of movement. But yes, this sort of thing is a very common thing in robotics competitions, where even at international levels, as in if you have a competition where teams are selected from regional and sub-regional competitions, and a small mistake in the program or one error that they forgot to check could cause a run to be quite could get the robot stuck in a place regardless of the actual details of the competition. And I think myself and Andy has experienced this in the past as well.
Yep, I definitely have, at least.
Well, we have a couple of more seconds left. And that's it for Orca Robotics. Unfortunately, they couldn't score any points. It was probably some small error with their misidentification, but we can talk to them after the block.
Solid effort, though. And so we'll go directly to the next team. So next up, we have Nisshin Yasui.
All right, here we go.
And go.
Let's go. So in the last two teams, we had the introduction videos explaining what their algorithm does and how they managed to solve the problems they encountered. This live event, as well as all of the runs, will be posted on the RoboCup Junior Rescue website, where all of the other information for this event as well as previous events are on. So we encourage teams to go look at them and see what other teams have implemented and how they solve problems.
We'll also have a few slides at the end of the presentation to give more information on that.
But at the moment, while we have just spoken about this, Robot has managed to go out of the first room and navigating in the second room and doing a pretty good job right now.
We'll see if this obstacle, if he can get past it.
It's a little bit stuck here. And also the movement of the robot is a little bit jittery, but although it's a bit jittery, it's able to go through the maze at the moment. So that's working really well. So reading the introduction video, essentially what this team is doing is they follow the right-hand wall or left-hand wall. I think it's the right-hand wall. And once they finish navigating all of the path and going back to the start tile, they try to look for any unexplored tiles and move to them. So hopefully, in theory, the robot should.
They've
Yes.
obstacle.
Yes, yes, exactly.
That seems to pose much trouble, so it's good to see a team be able to get past that.
And it seems to be back on track as well. Oh, is it going to be stuck again? Maybe it'll go out. Maybe. And it's a bit stuck. We'll leave it for a couple of seconds to see how it does. But sorry, going back to what I mentioned. Oh, sorry. Oh, it's out of the obstacle, which is good news. Back on track. We'll see if it goes to the third room. And it is in.
Nice job.
Nice job. All right. So yes, regards to the algorithm, they will follow the right-hand side of the wall until they go back to the start tile, and with before exiting the maze, they will move to the unexplored tiles, so all the floating tiles, and try to explore for any victims that they have found in the floating tiles. So we'll see if this algorithm that they've implemented actually works. But so far, it's been doing exactly that, following the right wall pretty consistently. It's also identifying the victims correctly. So they've implemented some kind of distinction between the H, S, and U victims.
It's doing very great, as we can see. It's in the last box, and it's gotten almost every victim it's passed so far. So
if this keeps going at this pace, it's a pretty good candidate for perhaps perfect score, maybe. We'll see if this happens.
it's even getting the victims on the very side, so that's very impressive.
Yes. The slight difficulty for the robot is the robot is quite slow compared to some other ones. So it's going cautiously, which is a bonus, but it is also taking up some time. So we'll see if the robot manages to navigate through the whole maze in time in the given 8 minutes of the competition run.
Yeah, it's definitely on the edge of there. As you can see, we're almost at 3 minutes and 30 seconds. It has to go all the way back and possibly all the way back to get the floating tile it left there.
An interesting observation is that it's almost gone through this room with the holes, but it hasn't marked the holes as walls, so you can see it's checking the hole tiles every time it's encountering them, rather than marking it off in the map as a restricted area, which could be a bonus because it's cautious, but it also would take a bit more time.
Mm-hmm. I feel like the main thing that might go against this team is time itself.
Yes, and the obstacles are not really helping at the moment, but
yeah,
luckily the team has got out of the obstacle, so that's doing pretty well.
Hopefully it doesn't have as much trouble with the obstacle when it comes back to it.
Yeah, it's impressive. It hasn't done a single lack of progress, and found all of the victims, in fact, that was on its path. So it's very promising how this is going, but we only have 2 minutes left. It's found the checkpoint. It's going back to the start tile. So as with other teams, if the robot goes to the start tile and calls a exit, then the game ends. So there's no more opportunity for a robot to gain any more points. But if they don't call, they don't need to call an end of like an exit call, and they can search for more victims.
Hopefully they'll have enough time to do everything they plan to.
Exactly. So that was another identification.
I don't know how far they'll be able to get to the floating tile with a minute.
We'll see if they chooses to do an exit or actually go back to the floating tiles. So that's the start tile. And yes, as expected, they've gone back on track, and
now it's not on time.
Yeah, now it is really on time. It's but it's going pretty efficiently towards the floating walls, which are on the opposite side of the room, which is quite far away from the robot. But maybe we'll make it, maybe we'll not. We've got 30 more seconds. We'll see what happens.
It's a mad dash. Oh, they're almost there. They're like
this is another common scene in RoboCup where you have 8 minutes and the time is running out, and there's a couple of more points that robot could get, but we'll see if it can within the time frame.
We're on the 10
seconds. 10
seconds.
seconds.
Down.
10 seconds.
Uh-oh.
Very close, very close. Oh, will it get it?
Oh,
there's a victim right there.
I think it's too
Oh, so close.
No.
So close. But incredible effort. 270 points. I think that's the highest we've seen so far.
Yeah.
With a full game time of 8 minutes. Congratulations. Impressive. And now we move on to the next team. So up next, we have Team Apples. Let's see their introduction.
And my teammate is Levi Zhang, and our team name is Apples. We have had a lot of fun in preparing for this competition, and have learned a lot throughout the process, and we are very excited to compete this year. Thank you.
Right.
That's a go.
Here we go.
So it seems like they're doing some smooth turns and movement.
Yes. It's nice and slow. It's nice and steady. And it seems like they're doing at the moment, it seems like they're doing following the right-hand side of the wall. But we'll see if the other algorithms are implemented.
That's 20 points for heat detection.
Yes.
There are definitely benefits and downsides to moving at a slower pace. On one hand, it's more accurate, but on the other hand, you have less time. So it's really about judging the weights of them. Like, do you want more accuracy or do you want to finish in time? So
it's always a difficult issue, especially with the fields getting bigger and bigger towards the more advanced competitions with more elements in the field, such as this one. Then you cannot sacrifice time as much, or else you won't get a really high score. But you also cannot throw away the accuracy, and it's always a trade-off there.
There's only a way to have speed and accuracy.
Exactly. And we'll see if we'll see if some teams can pull this off, having both speed and accuracy.
Mm-hmm.
But at the moment, the robot is being sped up because it's navigating similar parts of the maze.
Hopefully, it will be able to maybe pump into one of these victims and score some more points.
Yes. So it seems like the team was able to do victim detection for the heated victims, but not really for the visual victims. And we should ask them about how they did their maze navigation.
Unfortunately, that's a lack of progress.
That was a lack of progress.
It's
And
back into the
robot,
tiny compartment.
robot has another minute to explore the field and see how it will see if it can get any other victims. The easiest one would be the heated victim on the top right of the screen, but we got 8 more seconds, and it's a bit difficult to achieve that at the moment. And that's it for Team Apples. Right, so they had a good start. they got the right hand wall following working, but I think the robot got confused halfway through, probably with some issue with the GPS. But we can ask them. And that was 15 points for 8 minutes.
So without further ado, we'll go into the last team of this scheduling. So up next is Tux 2.
Hi, I'm Aura Merit Kampf, and together with Merit Lea Wilczek, I belong to the team Tux 2 from the Gymnasium Raden in Germany. This is our mascot Freddy. We never participated in rescue maze simulation before, and we are excited to take part in.
All right, here we go.
And we're off.
So the robot seems to be a little bit stuck at the moment in this area, and we'll see if it is able to go out of this compartment.
Yeah, hopefully it'll recover. But for now, it seems like it'll just be in this area.
From what I see, the robot seems to be using its distance sensors on the left-hand side and the right-hand side to simply move to the other way if it sees a wall nearby. And unfortunately, the current maze setup is not forgiving with this strategy yet, because it keeps on going back and forth. But maybe, just maybe, they have a way to go out of this.
On a brighter note, the robot is very consistently moving in this section.
Yes. Once again, in a different competition setup where the teams can call a lack of progress, this could be an issue avoided quite easily. But the way we have decided to run this competition, the teams will just have to keep going and see what happens with the robot, since it's the organizers who are running the programs that teams have submitted. So as we speak, 8 minutes is almost over. So we're on to our last 10 seconds. And that's it for teams Tux 2. Great effort. We'll ask you questions after this, but that was the end of the second block. So it's good to see 5 teams running here, and hopefully we will get teams on the Zoom call with us right now. So do we have anyone from? Okay, so we have Orca Robotics, the second team that went in this run.
Hopefully we'll have other teams joining us soon too.
We wait for a bit, and then because we're slightly ahead of time, but once if we have, let's give it another minute and see if we get anyone else on the Zoom call with us. So, okay. Well, it seems we only have Orca Robotics at the moment. So, hello, can you hear us?
Hello.
Looks like we got another team.
Hi. So it was okay. It's good to hear you. So can we ask some questions?
All right.
So in the introduction video, you mentioned about how how you implemented your maze solving algorithm and also the letter detection. One particular thing I was wondering is how you identified the victims after cropping and adjusting the pixel intensity. So if you could explain how you did the victim detection, that would be great.
So we
we have been testing it. We made arrays which contained values, and it was like the letters.
Mm-hmm.
And we compared the letters with these arrays with values.
Right. I see. So you basically had a kind of like an answer key of H, S, and U, and you had your detection that you took, and you kind of, I guess you had zeros or ones and multiplied the same values, or added the two values and see which one had the highest value to see if the victim was an H, S, or U.
Yes.
If that makes any sense. I see. Another question. So your robot unfortunately got a little bit stuck in the beginning of the maze. Do you have any kind of reasons or why you think it got stuck, or how it was originally intended to move?
It's not finished.
Okay.
We should improve this program.
Right. I see. But okay. Can you explain a little bit about your maze navigation algorithm? Because you had some things in the introduction video. It went over a little bit quickly, but you had some kind of grid grid method. So you had like coordinate systems on each of the tiles, and you were trying to go through all the tiles, kind of thing.
Yes, there's something that we planned. It's connected to the scores of the tiles and the walls, but we didn't finish it. So we just move straight if there's no swamp or hole or wall in front of us, and we turn right or left randomly.
I see. That makes sense. Okay. Do you have that's it from us, actually. Do you have any questions for us as organizers, or do you have any questions for the other teams? Except it's only Team Friends on this call at the moment.
Yes, we have a question. Can we download the map that the competition map? So can we see it later?
Yes, I'm sure we can. We haven't set that up, but we will post it on the website as in the similar place where we had the like practice maps. So yes, we will make that available afterwards.
Thank you. It's great.
No worries. Okay, so
it seems like the next team we have up is Friends, and so if you could come on mute and we'll ask you some questions, that would be awesome. Hello.
Hello.
So, in your competition run, we saw some very unique 90-degree turns, and the same thing with going straight. So, could you explain how you performed such accurate 90-degree turns and how you went so smoothly?
So, our 90-degree turns were done using a custom gyro PID controller. We tuned that extensively, and our forwards were just we used the set position function in from Weebots, and we found that PID, that distance PID, was adequate for our uses.
So it was a PID controller, and
Yep.
could you explain more on the system of how PID works?
Right. So PID is a feedback loop controller. Basically, you have a sensor value that you're comparing against. It could be a gyro, it could be an encoder. You have your current value, and then you have a target value, and you can basically take the error between that and multiply it by a small constant factor to get an adjustment to your motor power. And PID consists of 3 different kinds of these feedback controllers: the proportional, the integral, and the derivative term. The proportional changes your current error. It affects your current error. The derivative error takes the change in error from the last time you ran your feedback loop, and the integral term takes your overall cumulative error. And all these, when added together, give you a nice, smooth feedback control loop.
Yeah, we definitely saw that in your program. As you can see, you had extremely accurate turns, and you had very nice straight movement. Anyway, could you also explain how you did the visual detection? As we saw, you did move your head to the side to see visual victims, I'm assuming?
That movement was actually for obstacle because we did not have a direct front sensor. The sensors were sort of on an angle, so if we had to see directly in front of us, we had to do that 17-degree turn. We detected victims in the previous tile. We took basically 3 snapshots using our cameras, and then we ran the Tesseract OCR machine learning algorithm on those images after a bit of pre-processing, and it gave us pretty good results.
Wow, very advanced. Yeah, we saw that your letter detection was extremely good. We thought the head moving was to see those tight corners, but it seems like you took a frame of the previous one. So very great job. And also, did you use any Python tools for, did you use any of the OpenCV, or was it exactly Tesseract on the?
No, we had to do OpenCV because the image was, there was quite a lot of stuff in there. So we had to do thresholding, grayscaling, and all the standard pre-processing functions to actually isolate the letters. And then we could do recognition using OCR.
Very great. Also, lastly, could you explain a bit of your maze navigation process? In the video, I think you mentioned how you use breaths for search.
Yes. So what we do is we first navigate based on our sensors. If we see a wall in front, we'll turn. If we see a wall to the left, we'll mark all these walls, and we'll do a sort of distance sensor-based navigation. And then once we get to a tile where all of our neighboring tiles are either visited or there's a wall all around us, like 3 walls, then we initiate a breadth-first search to find the shortest path to one of our unvisited tiles, and we store our whole map in a array, and we do a breadth-first search on that array to find the closest unvisited tile, and then we go there.
So that's all the questions we have. So great job, and yeah.
Do you have any questions for us, actually? Also, before that, that was a great explanation of PID control. So that was nice.
I don't have any questions for you. Thank you for hosting this. Hope to participate again in the future.
That's great. All right. Okay, I think you don't have any participants from other teams at the moment, so we will call an end for this Q&A session. So thank you for Team Friends and Team Oracle Robotics for joining this call once again.
Thank you.
So the next thing we have is a coffee break at 1:30, but we have some time until then. And I think I wanted to highlight a particular video from a previous RoboCup Junior Rescue event, which was the presentation competition. There was one team which actually used a simulation for tuning their robot and testing their algorithms, which was really nice to see. And this team actually used Minecraft to both test their maze-solving algorithm, but as also a way to record what the real robot is doing in real time in Minecraft. So we will show a edited video from their presentation event. This is also on the RCJ Rescue website, so you can check them out. But we'll have a look, and I hope it will be inspiring to participants and other people.
Definitely
right.
amazing.
That was a really cool video. So you were able to see how, especially in the second half of the video, where you have the robot moving on the right hand side and the maze was being built, but you can actually visualize it in Minecraft, which was a really cool thing to see. And I think it's quite relevant to this competition and how simulated efforts can be used to actually tune real robots as well. So yeah, I think that was a nice video to show. What do you think, Andy?
I thought I've never seen anything like that, like the creativity to put a maze simulation in Minecraft. I mean, the possibilities in Minecraft are definitely great, and I thought that was a great way to use them. Like, there's so much you can do, and I guess a maze simulation is one thing too.
Yeah, indeed. All right. So I hope everyone enjoyed that mini clip before moving on. So we are slightly ahead of schedule. So we are currently 4 minutes ahead of schedule, but we're going to move into a coffee break now. And at 1:40 UTC, we will regroup and start the second half of this live event, where we go through the other 9 teams. Starting with Jano team from Argentina. And after that, we will have another coffee break and then finally an award ceremony. So that's it for the first half. I hope everyone enjoyed it, and see you back in a few minutes. All right. We're back on again. Hello, everyone. So before we start the second section of this event, we're just going to go through our introductions and also the rule explanation, because apparently there was some technical difficulties in the first half and the audio was cut off. And also new people could be joining in from the second half. So we'll go right into our introductions. So my name is Kai Junge. I am the current RoboCupJunior Rescue Technical Committee Chair. But at the same time, I've been a participant in the RoboCupJunior Rescue League in Rescue Line from 2010 to 2015. And you can see some photos back in the days. I'm currently also working on RoboCup Major competition, so Major Rescue, and also have participated in the Rapidly Manufactured Robot Challenge. So I've been in the RoboCup Junior and Major Rescue community for quite a while.
Hello, so my name is Andy Chung, and I'm a current participant in RCJ Rescue Line. I have participated in the RCJ Internationals 2019, and our team was a USA National Champion. We also got Best Overall Award for the RCJ Rescue Presentation event in 2020, and I'm a current robotics instructor, robotics instructor for younger students.
All right, so that's it for our introductions, and let's go to a rule explanation.
We will now explain the rules of the competition for you to better understand and enjoy the runs. This is how the field looks like. The green box is a start tile, and the robot will be placed here initially. The silver tiles are used as a checkpoint. When the robot gets stuck somewhere or a lack of progress happens, it will be placed back to the most recent checkpoint, and the run will continue on from there. The robot must traverse this maze to find as many victims as possible within a time limit of 8 minutes. There are two types of victims, heated and visual victims. The visual victims are subdivided into H, S, U, which stands for harmed, stable, and unharmed. The robot uses its temperature sensor and the camera to detect these victims in the field. If it can identify which type of victim it has detected, additional points will be awarded. The points for each victim depends on whether the victim is placed on a linear wall or a floating wall. Linear walls can be reached from the start by strictly following the left or right hand side of the wall adjacent to the robot. 10 points are awarded for detecting victims on linear walls. Floating walls cannot be reached simply by following the left or rightmost wall from the start tile. To systematically detect all victims on a floating wall, robots must have some mapping and navigation algorithms. 30 points are awarded to detecting victims on a floating wall. This is significantly higher than that of the linear wall because of its difficulty. Finally, there are other hazards for the robot to overcome, such as swamps, holes, and obstacles. A robot can go through a swamp, but its speed can be reduced by a third. Robots must avoid holes or else it will fall into them, causing a lack of progress and penalties on the score. Swamps and holes can be detected using a light sensor underneath the robot. Obstacles are placed to block the path of robots navigating around the maze.
All right, so that was it for the rule explanation, and we will get right into the third block of this event.
So the
First
team
we have Channel Team, Ite Salta,
We
Argentina.
are Team Janus from the IATA Institute in Salta, Argentina. Our team is composed by
Máximo Cancino,
Máximo Rivero,
and Alejandro de Garriza, and our mentor is our Professor Gustavo Vielas. We aim to beat this challenge via our advanced maze mapping system that converts the distance sensor data to global coordinates, smart movement planning and navigation using the A-star and breadth-first search algorithms,
precise victim and character recognition with OpenCV,
and seamless interfacing with Airbus controller.
We learned a lot preparing for this competition, and we are very curious to see how our program performs in comparison with those from other teams.
All right, here we go. The first run of the second half of the competition, and we'll see if their navigation system works as well.
So far, it seems to be doing pretty good.
Yes.
Might get this.
The intro video was very impressive with real-time mapping from the distance sensors into a map and then converting that into like a grid and nothing in
Definitely.
space. So
It's
yeah, we'll
slightly
see.
almost like that Minecraft video we saw where they almost showed a visual representation of it.
Exactly. So, but the robot is doing really well at the moment. It hasn't been getting stuck anywhere and accurately moving. And you can see there was a team in the first half which did the same, but their turns are really smooth and accurate. So it seems like they're also using some kind of feedback controller for the turns and going straight between tiles.
Definitely agree about that. Another heat victim?
Yeah, got a heat victim. Their breath first algorithm seems to be working as well. Going every node and seeing where to traverse. Now it's in the third room with the 4 holes without any walls. So we'll see how it does in this place.
Oh. Uh-oh.
That was the first. Oh, okay. So the robot apparently fell in the hole, and after a lack of progress, it exited. So that's the end of game for this team. We'll ask how they have done after the other ones.
So without further ado, we'll go on to the next team. So up next, we have Itanaba.
Ci sarà l'Italia, un'Italia zona protetta. Saranno quindi da evitare su tutto il territorio della penisola gli spostamenti, a meno che non siano motivati da 3 specifiche circostanze.
6 months later.
Right, here we go.
And we're going.
that was a cool introduction video.
Yeah, I think that was my favorite before.
Pretty entertaining. Yeah. So it seems like they were a Rescue Maze participant from the very first slide with the real robot. So we'll see how their algorithm is able to tackle with the simulated world. At the moment, it's doing some interesting stuff here. It's moving backwards to go through the tiles, which is something we haven't seen yet.
It also seems to be very, very cautious, as you can see. It's like turning to face each tile to make sure if there's a letter and to arrange itself.
Yeah. But it's going well. It's doing well. Yeah, like you say, there's a lot of turns that happens every tile, and I guess this is for never missing a visual victim. But we'll see how it does with the 8-minute time limit and the whole large field it's navigating.
Speaking of that, maybe the backward driving is like a method to almost save time.
Yes, it's if it realizes there's a path that you could go behind, it just goes. But we'll see if it can identify this, and yes, it has correctly identified it.
Nice job.
So that's another 20 points. We'll see if the robot is able to correctly identify all the other visual victims as well.
Yeah, and very, very cautious. So far, it's doing
Yeah,
really
so far
good.
it's doing good. It's about to reach the second room of the competition field. Speaking of the setup of the competition field, there's no indication of rooms in the rule or anything, but you can see there's one tile width that the robot has to go through in order to move between the 4 areas, and this means that a random kind of movement will not be very tactical, and the robot needs to probably use some kind of algorithm to systematically go through the maze, which most teams have been doing, and it's very impressive. They also managed to correctly identify the S visual victim as well as detecting it, so it seems like they got a nice visual victim detection algorithm going on.
Definitely agree about that. So far, though, it's on the second room, and it's about 5 minutes in, so yeah, definitely a bit time-consuming, but so far, I don't think it's missed any single victim.
Yeah. Yeah, it's slowly but surely going through everything. We'll see how it does with obstacle. Oh, that was quick. It didn't get stuck there.
Great job.
Great job. That's a hard point for a lot of teams, it seems. So we'll see how it does. And we'll see how it does in the room with the holes, and if it will manage to avoid it or not get stuck anywhere.
Another point to add, I feel like definitely how it centers itself every time on each tile definitely helped with the obstacle. As you can see, it was able to quickly move out of that area.
Yes.
And regain its positioning.
And it has 4 minutes left. And moving on to the third room. It's gone to the checkpoint. So it currently has 130 points, which is quite impressive. We'll see if it can gather up a couple of points from all the other victims.
Well, let's see this victim.
This victim is quite difficult. It's in the corner.
Yeah,
and we'll see if the robot can find it. And unfortunately not. Doesn't seem like it's doing a good job at finding the ones in the corners. But that's quite difficult, especially with the camera mostly pointing straight onwards.
Definitely one of the harder victim detections.
Exactly. But the maze following has been pretty good so far. And given that they're using like a depth filling algorithm, it seems, they can probably move onto the floating walls victims as well, which is 30 points compared to the ones on linear walls. On a slightly different note, in the last block, there was a request to post the request to have the competition field available to participants, to the public actually, and then this will happen in the next few days on the website. So that has been confirmed. In the meanwhile, the robot has gone over to the other, like the opposite corner from the start tile all the way, and it's doing a fairly nice job at systematically going through all the tiles, which is good to see, and it's a key factor for a maze following robot.
It does have about 2 minutes left, so
yes,
it is a matter of time.
Yes, it is in fact a matter of time. It has missed the floating walls, and we'll see if it actually goes to them. And yeah, it seems like it's going to this victim, and it should get quite a high point. There we go,
Very
30
impressive.
points.
Wow.
That's 220 points right now, and depending on how well it does in the next 1 minute and 20 seconds, this could be a pretty good candidate for coming in the top 3.
We'll see if it manages to get this floating wall. There is a victim in here also.
There is a victim in here indeed, yes. That would add another 30 points and getting close to the top team so far.
Did it see it?
Has it missed it? Oh, unfortunate.
Oh, no.
That was close, but it could have got that, but it seems that it didn't. It just about didn't capture this one. We'll see if it can find this victim.
It does. Nice job. The robot, I think it seems to be going to this corner for a possible heat victim.
Yes. Got 10 seconds, but will it manage to identify the victim?
Hopefully, we're very close.
Yes, just about.
Nice.
360 points. That was a great run. That was a great run from Etnabot. Congratulations. We'll now move on to the next run. Okay. So next up, we have Team Prime, and we'll look at their introduction video.
Hi, my name is Jonathan Zhang, and for this project, my partner was Jeffrey Wang. Together, we created this code to run in the Weebos competition. I mainly focused on the environment and detecting victims, and Jeffrey focused on navigating the maze and all the functions to move around. To navigate, Jeffrey used an algorithm called breadth first search to make sure that the robot navigates all the tiles in the maze. And then one main part of my visual victim detection was the use of the OpenCV library, where I created code to detect the letters. I hope you look forward to these functions while running our code. Thank you.
And that's
Right.
it.
Here we go. This is another team using C++ for their robot controller. We'll see if the breadth first search algorithm that they implemented is successful. It's going quite quickly. And it didn't manage to find the visual victim just then, so maybe it has a second try on the other visual victims that it finds.
I believe it's almost going on the left-hand side.
Yeah, that's what it looks like. And the visual victim seems to be slightly an issue for the robot. Like some of the other teams, the robot is doing this kind of like a head shaking when it goes on the wall, and maybe that's about the obstacle as with before, but it could be with the visual victims. Who knows?
Yeah, definitely have to get the full view of the image to make sure you're correctly identifying them.
Yes. Yeah, like you mentioned, I think it's going on the left side of the wall, actually. Although that's been pretty successful at the moment. So, yeah.
The majority of teams seem to be doing like, they track one side of the wall all the way to the end, and then they go back.
Yeah, that seems to be pretty common. And also, I think it's a pretty quick implementation, because you get like 2 sections very distinctly in the program, where the first one is just going along the walls, and the second one is identifying any unchecked tiles. But oh, the robot seems to have stopped for some reason.
Come back.
What's happened?
We can hope.
Not really sure what's going on, to be honest.
Oh no.
Okay, all right. Well, that was another error. So we have to investigate what all these errors are. It's a little bit unclear. The but yeah, we cannot do much about it at the moment, unfortunately.
Great job.
That was Team Prime.
So we'll go on to the next team.
Yep.
So we have Team Integral.
Right, Team
And that's
Integral,
a
here we
go.
go. We'll see if their maze navigation system is will do well. We definitely have to ask them what they exactly meant by mapping the maze, because they have some explanation, but some more comments would be more helpful for other teams as well. But as it seems, the robo is a bit confused about what's going on at the moment.
Yeah, definitely seems like that. Hopefully it'll be able to regain its pace.
Yes. Yeah, it's difficult to. The difficulty here is that there's no automatic lack of progress by the game controller, because the robot is not. It's technically moving, except it's just moving on its spot.
Yeah.
It's a difficult decision for the operator to call lack of progress, but I think that was one right there.
Hopefully it'll be able to fix itself up and get some points from victims.
Yeah. Oh.
Sped up now.
Yes, it's sped up a little bit, and then we'll see if this, if they manage to find a exit from the current loop that they're in a little bit. Maybe.
Maybe.
We'll see. It became slower. So that could be something. Oh, very close. It's confusing to what exactly is the underlying method of navigation, but yeah, it seems a bit stuck now. Maybe a lack of progress will be called.
Possibly.
Yes, now.
Yeah.
Yes. We'll see. We'll see if robot does as well, but it's not very promising at the moment, unfortunately.
Mm-hmm.
And yes, it's having some difficulties getting out of the first room and the first part of the first room, but we'll give it the full length to have any chances of reviving from the situation.
Yeah, unfortunately, it seems to really like this area.
Just as the robot is doing, perhaps a kind of an announcement or notification to teams is that this is actually the so we started the development of this platform over a year ago, actually, technical development, and this is the first competition. So as much as the teams have been excited to write their code and participate, we've been excited and working hard to get the competition up and running. So we're also in the same boat of learning how to adjust to new standards and also running this competition live. But following this, we're scheduling to have another demonstration competition at the RoboCup 2021 Internationals in Bordeaux, France. So that could be exciting news to participants that are in this competition, as well as new participants. Oh, we're just moving quite a lot. New participants trying to get into the world of simulation and seeing what they can do with implementing complicated algorithms. But as we speak,
time's up.
Yeah, the robot has time's up, 8 minutes up, and that was the end of the run for Team Integral. So we shall ask them if they turn up about their algorithm and what went wrong.
Great effort.
All right. Up next, we have team TFA 309.
Hello everyone, my name is David and I came from TFA 309 from Canada. And my job in this team is just to test our robot's reliability. And in order to do that, I just create new simulation worlds that can make our robot fail the test or get less points. And also at the same time, I'm the lucky charm in our team. So let's go TFA.
My name is Leo. I'm responsible for maze navigation. I program the robot to explore the maze as much as possible. I use GPS and gyro sensors to adjust the robot's movement.
I am Victor, and I am responsible for the data visualization and victim detection. Basically, I get the sensor's raw data and I graph it to find patterns. In victim detection, I use OpenCV to find the H, S, and U.
All right, that seems promising. We'll see how they do.
Wow, very quick.
So one of the key things that was mentioned in the presentation was that one of the teammates was responsible for reliability and robustness of the robot, which is quite overlooked because a lot of teams spend a lot of time actually making the robot and making the program at the beginning. But especially for these autonomous robotics competitions, it's key for the robot to have some robustness and reliability for different kinds of fields and types of obstacles or different scenarios that could happen. So I think that was a wise choice by the team to allocate someone for this task and run the robot in many, many different situations.
You can definitely see their reliability. As you can see, they have not missed a single one and they're almost blazing through.
It's doing a pretty consistent run. And it seems to be, it seems to be doing a fairly consistent job at going through the maze. It seems to be doing following the left-hand side of the wall at the moment. We'll see how it does with the floating walls in the upcoming section of the competition field. But yeah, it's been very smooth, finding all of the victims and identifying them correctly.
It even managed to get one of those harder corner victims we saw in the previous.
Exactly.
And it managed to get the side view of the letter.
Yeah. So yeah, it's just doing really well. And yeah, it's able to detect the maze. It's able to detect the like you say, the visual victims that are on the side of the walls without actually facing that side, like just going past the wall. So it's probably taking some images as it goes through the corridors and process it right there. So
I think it missed one floating wall, but it managed to get the other.
Yeah, it did. So
Or may have gotten both. I'm unsure.
no, I think you missed the other one, but we'll see. So far, it seems that it's following the left-hand side of the robot, of the wall. So it would be difficult to get the other floating wall, but we'll see how it does.
So far, it's just doing like there's no other words to explain it than just amazing.
So it depends if the robot it's going back to the start now, and maybe it will do exit, or maybe it will actually go back to the missed floating wall. And if it does, it's pretty amazing because it's gaining some good amount of points here.
It's going go.
It's going back. It's going back. That's pretty impressive. So I think this is the same algorithm as some of the past teams where they go around the maze on one side of the wall, and then once they reach the start tile, they have a second algorithm where they try to identify any missed walls and will move towards them, and it's doing that really swiftly so far.
We may see a perfect score. It does see it.
Yeah, it's got the final victim, and yes, it's doing a very smooth run, going back to the start tile. It seems. I think if I'm not wrong, I think that's all of the score. To be honest, I think it's everything.
I totally agree. This may be it.
All it has to do now is go back to the start tile and call an exit. But it's looking at it will do it, and then
it's right there. Oh,
it's right there. And here we go. That's a perfect run. Congratulations. That's really amazing.
Amazing.
Incredible.
Great job.
Great job. All right. So that was a TFA 309. Perfect run. And not just that, but the game time was really quick. It was 4 minutes 46. So yeah, it was the best one so far. It will be pretty difficult to top this one because it needs to have both accuracy and speed. But we'll see if there's some other teams that are able to reproduce the same level of accuracy.
Fantastic though. Like I mentioned before about accuracy versus speed, I think they managed to combine both in this case. Wow.
All right, it's great. We'll see how the teams do competing with these guys. All right.
So it seems like we'll jump into the Q&A session now, and we'll invite the teams here.
Yes. Okay. So, do we have teams from this block? So at the moment, we don't have anyone from this block, unfortunately. And I guess we can wait for another minute, and then we got two teams. Oh, yes, we got
TFA 309 and
we got so we got 3 teams. That's great. So we got the Channel's team. We got TFA 309. We got EtnaBot. We're waiting for the other 2 at the moment, but we can have a go. We can start with the first team that went on this block, which is Channel team. Hello, can you hear us?
Yeah. Do you hear me?
Yes, I hear you.
Okay.
Hello. Am I pronouncing that right? Jano team, or is that
Sí, Jano, sí.
Okay,
Yes,
I
yes,
see.
yes.
Yeah. So you started off really good, but then unfortunately you fell in the hole.
That was the last thing we imagined it could fail like. We tested
Yes.
a ton of times and never did that. And we were worried about that obstacle that was everyone else was having trouble with it. But no, it was the hole, and yeah, that was totally unexpected and well, a bit disappointed, but
did you? I'm assuming of course you had some algorithm to, or it had like a sensor to avoid the holes, but maybe it was not calibrated correctly or something like this.
Yeah, we I mean the theory we have to why it failed is maybe it miscalculated like the position of the color sensor to one side, so it mapped the trap in the grid in the virtual map is making in another position or something like that.
Yeah. So can you explain how the mapping was done, because you had some cool videos in the beginning with real-time mapping using the distance sensors.
Oh yeah. We use the distance sensors. Then we convert that data. We don't actually use that like raw, which individual points mapped. We convert that to say there's a wall there, there's an object there, there's a trap there.
Yeah.
So we represent each tile as opposed to a bunch of nodes with each individual detection or something like that.
Yeah.
And yeah, we use the breadth first search and A-star to navigate.
Yeah, it was doing really well. How did you go from point cloud to the grid kind of representation of the maze?
Yeah, we with the GPS coordinates, assuming that the robot starts in the center of tile, we did it so it will map a wall when it detects at some point that is in the position of a possible wall. Like,
yeah.
Yeah.
All right. Yeah, cool. Do you have any questions to Arstad or any other teams in this call at the moment?
No, really. Just wanted to thank you and the Airbus team. They were very kind with us with the Discord and answered all questions. So thank you.
You're welcome. Cool. Up next, we have Etnabots.
So we have just a few questions for you. So you mentioned.
Can you guys hear us?
Yeah.
Okay.
Hi.
Good. Hello.
So you mentioned you did the in-person maze competition. So how did that compare with the simulation?
So it was a little bit more difficult because with the simulation we can test various types of maps, various types of maze. In the maze, in the rescue maze, we had to build the maze on a ping pong table. We had all the ping pong table with the maze, but it was a lot harder. If we were not at school or schoolwork was closed, we cannot test. So this was a lot easier.
So also talking about your systems you used, we noticed that you had you had a heavy checking process. So do you think that checking each side of the tile was worth it?
Yeah, because at the beginning of the when we started to code, a lot of problems were caused by the robot going the wrong way. So we thought we check every wall, we realign with every wall we see, so at least we know that it goes straight where we want it to go.
Yeah, I definitely feel that system paid off. You did get an amount of points, so great job. And also, could you tell us a little bit about your victim detection methods?
So we used OpenCV. Every time we noticed a wall, we watched the wall, we took a photo and made the photo black and white, and with PyTesseract we detect what kind of victim it is.
Well, that's great. So, do you have any questions for us or any other comments to the teams?
No. Okay.
Okay.
Thank you.
Thank you very much. And last up, we have Leo from TF8309.
Hi.
Hello, Leo. It was a great run. First of all, congratulations for the perfect score. So actually, before we begin, before we begin, we have a question from the YouTube comments actually. People are asking if you will release your code online because I think it was very impressive. Do you think you can comment on that? You don't need to
I'm not
now.
so sure. Can we give a response later?
Yeah, that's all right.
Okay.
We can talk to you as well. But it was a question from YouTube, so okay. Going back to our questions. So can you explain a little bit of how your letter detection worked? Because the robot seemed to go down a pathway and then able to detect the visual victims seamlessly.
So the robot detects a white block before we enter the next tile, and then after we detect the white block, when we enter the next tile, we turn around to see which letter it is, and then when we see a big white block, we crop the middle of the letter and then compare between HSU and then to find the difference. Yeah.
I see. Okay. I have a specific question of one of the movements in the run. I don't know if you remember. If you don't worry. In the final area of the competition field, although the robot was doing a left, it was following the left-hand side of the wall, it kind of turned right and went to find the floating wall victim, and it actually managed to find it. Do you know why it did this movement? Because it was really curious.
So we had a mapping algorithm, so it was depth first search, and then we remember all the tiles we haven't gone to. So after we gone to the closest tiles, and then we go to the tiles we haven't been to before.
Okay, I see. Final question. We talked a little bit about robustness in the commentary actually, but did you test your robot on quite a lot of different maps before the competition in different scenarios, or how did you go about increasing the robustness of your robot?
So yeah, we created many worlds, and then about half of our developing time is just testing worlds and then finding errors and then fixing them.
Yeah, that seems like a very sensible thing to do for accuracy and robustness. Well, do you have any questions for us or other teams?
No, thank you.
Sorry, there's another question about your team from YouTube actually. How did you solve or negotiate the obstacles?
So when the robot's moving forward, we use the front distance sensor to detect the distance. If the distance is too close, then we think that there is an obstacle.
How does it distinguish between an obstacle and a wall? Is it does it compare the distance? If it moved one tile length and then found a wall, then it's a wall. But if it found something less than one tile length, it's an obstacle.
So we tested it, and then when there's a wall in the front, there's about 4 centimeters. But if there's an obstacle, it's gonna go below 4 centimeters.
Right, I see. Okay, so you're checking with you have the prior information about the tile length, so you can use that.
Yeah.
I see. Okay. Thank you very much. If you have no other questions, we will call an end for this Q&A session.
Okay, thank you.
All right. Thank you very much. Thank you to the 3 teams that participated in this session. We will go back shortly to the final block, the remaining 4 teams in this competition, and then that will be all of the runs. So yes, let's get back in.
So up next we have Tux Virtual.
Hey, we are Team Tux Virtual from Raden in Germany.
This is Steffen and I'm Janis, and this is the first time we participate on the simulation competition.
And we are very excited to see the results.
And we're going.
Let's see. This is an interesting participation, given I think they used to participate in RoboCup Soccer from their introduction video. So it's I guess it's a new category of participants. But
Yes.
we'll see how the robot does. It's a little bit stuck at the moment in the first section of the maze. Andy, it seems like this area of the maze is a quite difficult challenge for a lot of teams.
Yeah, I have to agree with that. It seems like they're unable to find this middle section where they can move. So yeah, definitely a challenge.
It's a simple setup, but I think for a given set of algorithms, it's very challenging. And I think the same can be said about the obstacle. Like there are these areas in the field that the robot finds it very challenging. But
They actually managed to get out. Oh.
Yes, exactly. It was we'll say that was very planned. And the robot came out of the section and it's a bit stuck on this wall at the moment.
Might be a lack of progress.
Yes. We'll see a lack of progress happens in a while, but yeah, there we go. That's lack of progress. And so one difference actually, not many people might know the rules for rescue line, but the difficulty in rescue maze and also in this particular competition is that a lack of progress will only result in going back to the previous checkpoint. Whereas in rescue line, the checkpoints are sequential. So if you do 3 lack of progresses, you can actually jump to the next one. So you can actually move on in the course. But the way the rescue maze and this simulation competition is set up makes it demanding for the robots to have high robustness and accuracy, which is the point of a rescue competition.
Yeah.
So it's a challenge, but it is also a key feature for autonomous robots to have.
Definitely. Oh, I'm sorry. You can go.
To navigate out of their situations. But go ahead.
Definitely, I feel like these rescue simulations and scenarios really highlight the unpredictability of certain disasters. I mean, they're meant to highlight the autonomous feature, how they almost have to overcome these variety of challenges, especially most of which are unexpected. So definitely an important feature.
It's interesting to see how the robot navigates around different kinds of areas. And in this particular competition, we have a flat map, but a rougher terrain, a different kinds of terrain would be also interesting to see, especially in simulation, and how that hinders or I guess helps the robot in particular ways. But as we spoke, the robot time has ended. 8 minutes has passed, and that was the run for Tux Virtual. So unfortunately, they couldn't get any points. But we go to the next run right now. So up next, we have expert robot thinkers.
Hola, mi nombre es Luca y soy el líder del equipo y también me encargo de crear el código para evitar las trampas y los pantanos.
Hola, soy Alberto y soy el co-capitán y encargado de los sensores de proximidad, sensores de color y su aplicación.
Mi nombre es Carl y estoy a cargo de las ruedas, los motores y el movimiento.
Yo soy Gilad y me encargo de crear el código que envía la señal y todo el proceso durante y después del rescate de la víctima.
Y mi nombre es Daniel Moscoso, soy uno de los mentores y bueno, entre todos ellos van a estar haciendo la implementación de las diferentes partes del código y así que la estrategia pueda ser unificada, el rescate de la víctima pueda ser hecho a la perfección y que todo funcione sin problema.
And we will start.
Right. If they come on the Q&A session, we shall ask them about what they mentioned in the introduction video. But the robot seems to be, once again, having a slightly difficult time at the moment, going around this first section of the field. But we'll see if it manages to get out of this and actually explore the maze.
Definitely seems like this common trend, definitely in the beginning.
But as we speak, the robot was managed to get out of this area and now going into the second room. So that's doing quite good. And it's going next. It's going next to the visual victim, but it was unable to detect it. And it seems like the robot is using the distance sensors to kind of reactively move to the environment rather than moving systematically in a planning-based maze navigation. So the upside of this is that the robot will move into different places, and even if it gets stuck, it will probably get out of there. But there's no systematic method of coming back or following the finding floating tiles.
Once again, this seems to be a really difficult obstacle here.
It's these two, isn't it? The first area, then the obstacles, which have been the difficulty of a lot of the robots actually. Unfortunately, the lack of progress starts from the very beginning because it didn't reach any checkpoint tiles. But we'll see how it does again.
Possibly heated victim?
Possibly heated victim. It's getting close. Maybe. Just about. But no, unfortunately not. Didn't do it. We'll see. He'll see if it can reach any checkpoint tiles or find any other heated victims and able to detect it. It's getting there. It's almost there. And maybe you will find it. And maybe you won't.
You barely just missed it.
We'll see.
Oh, sadly, he wasn't able to detect it.
No, it wasn't, unfortunately. I think without the victim injection capabilities, the robot can gain points by exiting or by going in the checkpoint tiles.
Hopefully, he'll be able to run into one of those.
Yes. But again, the way the rooms are set up, there's only one small pathway between these sections, and it is quite a difficult task for robots that are moving reactively to walls to navigate throughout the 4 different areas because of this setup.
Very true. Yeah, it almost was able to get out of this area, but it seems like it didn't
come back. Yeah. See how it does.
Maybe an inch.
Maybe there.
Unfortunately, I think it's mainly relying on the checkpoints for points. So we'll see what happens.
Let's see how it goes.
Seems to be in this room.
Here we go. Let's see how it does. But yes, it's a little bit like a Roomba from a top view, actually. Going around the room, hoovering the whole place.
Yeah.
But yeah.
The brighter side, it's explored this area very thoroughly.
Very thoroughly. But as we speak, I think time's running out, and this is the end of game for expert RoboThinkers. So unfortunately, they couldn't score any points, and we hope to talk to them in the Q&A session after this. Okay.
So we'll jump right into the next simulation competition. And the team up is Raptor B.
All right.
We're
Here we go.
I have to
That was
say,
a very
that music.
yeah, it was a
energetic.
very uplifting introduction video. I think it comes hand in hand with the previous one. That it was really nice. This is the team from the introduction video who also participated in Rescue Maze. So you probably have some know-how on how to do some maze solving, and we'll see if that goes up against test with the simulation competition.
Seems like they're following the right side of the wall. Again, another common trend for a lot of these simulations.
We'll see if they manage to go on the floating walls. But yeah, at the moment, they seem to be doing a really good job at going around the maze. And actually,
Great job
it
on
was
that obstacle too.
yeah, exactly. They proved the point before actually running the maze to the introduction video by showing their runs. So we got some evidence if anything has happened. But it's going good, so there's nothing to worry at the moment. So the robot has now entered the third room. It's navigating around the 4 holes without any walls around it, but it's doing a fairly consistent job at following the right side of the wall, and also not falling into everything. That was a little bit of an accident, because I think, if I'm correct, it seems like they wanted to move right into this area, but they hit the robot hit the wall, and maybe it thought there was a wall rather than the robot being slightly off-centered. We'll see if that affects anything.
It might be a problem in the future, because at least for this right section of the floating wall, because it may think that entire area is just blocked off.
Exactly, but it managed to get the victim on the floating wall right there, quite luckily, without the intention of thinking it's a floating wall, because it thought it couldn't go the right hand side in the very beginning. So I guess that was a bit lucky for the team. But yeah, it seems to be doing a very thorough following the right-hand side of the wall method to find all the victims.
It's really doing very consistent, very accurate. So
it's quite quick as well. Let's see if we can find this victim right there in the corner.
perhaps.
Yes.
Wow.
Yeah. So they also managed to get the correct victim. So they have a pretty robust victim identification process as well as just detection. And the robot is very quick as well. Only 3 minutes and 20 seconds has passed so far. The remaining time is 4 minutes 30 seconds, and the robot is basically halfway back. So if it can go back to the start tile and collect the exit bonus, that would be a pretty good score for this robot.
I do wonder if it will go back for the floating tile, because I personally don't think it will, because it did misread it as a wall. So
exactly. But if it did, that would be pretty impressive. But we'll see.
Yeah.
We'll see how it does. But
if
so
it
far,
does go back, we might
yeah,
have
that would be that would be great.
Yeah.
But so far, it's been doing consistently, finding the victims.
I think you missed it.
Yeah, I know. Yeah, I was gonna say it was missed as well. But yeah, let's come back and
very nice
exit. Very nice, very nice. That's 307 points. That's not a perfect run, but it's very close, and that was an impressive run. So congratulations.
I think that's a second place right there.
Yes. All right. And now we move on to the
Maze Runner. Very nice.
Hi, my name is Derek. My person name is Druva, and we're Team Maze Runner from Storing Robots from New Jersey in the USA. Our robot's programmed in C++ and includes a variety of things, such as a breadth first search navigation algorithm, letter detection using OpenCV for victims, and a PID controller in order to help our robot navigate through the maze more effectively. We hope you enjoy.
And we're
all right. Here we go. This is the final team of the competition, and we'll see how they do on the runs. So as they mentioned in the introduction video, they have a pretty smooth 90-degree turn, and also the PID system
definitely see that.
Navigate the maze at the moment.
So far, it's going great for them.
Yeah. Except they couldn't identify the visual victim, so we'll see how they do on the other visual victims. But other than that, the maze navigation seems spot on.
I did mention they were doing, I believe, a breadth first search.
Yes.
Yeah, you can definitely see that in this system as it is navigating all the rooms.
Yeah. So it's now going into a checkpoint. So if a lack of progress happens, it will move back to this particular checkpoint rather than the starting tile.
The obstacle.
So see the obstacle. Oh,
it just said no.
Decided to no. It's not going there. Very clever. I suspect that it thought there was a wall there rather than an obstacle, and it marked that space as a wall. So maybe. Oh.
It seems slightly off. Oh, good save.
So right there, I think it went off like one tile length because of the obstacle, but I think it recovered quite nicely, back on track. So hopefully the mapping is not messed up, and if it's not, then maybe it will be able to collect all the other victims as well. So I think it seems like it can detect most victims that are in front of the robot, but difficult to detect them that are on the side, it seems. And also, it just avoided the swamp. I think that's the first robot that actually avoided it, rather than.
Yeah. I was just about to say that. I was like, I didn't know if it accidentally hit that wall on the right side, or like specifically avoided the swamp.
Yeah. I guess that's one way of doing it, avoiding it completely and treating it as like a black tile. But we'll see. So it's coming back. It's doing a fairly good job at collecting points and looking at victims. We'll see what it can do in the remaining 5 minutes. Because the robot could move all the way back and all the way back again to the start tile in the next 5 minutes. So it will definitely have a chance of successfully collecting all of the victims.
It's doing very good so far, though.
Yes, it is.
It's got a majority of heated victims, as well as the checkpoints. Oh no, is it stuck here?
So it's getting a bit stuck here. We'll see how the robot. Oh.
Okay.
Navigate it back. I think this robot is doing a pretty good job with obstacles. Maybe.
Maybe.
It's an interesting algorithm. I'm a bit yeah, I guess it's breadth switch, but yeah, it's not as easy as it's not as intuitive. Oh
no. It seems it was terminated due to an error.
All right. So unfortunately, that was the not the most exciting ending, but that was the final run for this competition, and that was a score of 135 points in a game time of 3 minutes and 48 seconds. So
amazing job.
Well done. And now we've actually finished going through all of the runs. So I hope everyone enjoyed them, and we'll have a final Q&A session with the 4 teams that just went on. We got Tux Virtual on. We have Raptor B. And it seems like these are the 2 teams that registered for the Q&A session. So we'll first go with Tux Virtual. Can you guys hear us? Maybe. We'll give another minute, and then to them to get the audio working.
Hello, can
Hello?
you hear me?
Yes, we can hear you.
Hello. Okay, nice.
Yeah, that's good. So we have one big question for you, which is how did you find going from RoboCup Soccer, I presume, to RoboCup Rescue, and also simulation? Because that seems like a pretty big jump from a different league.
Can you repeat that, please?
So in your introduction video, we saw some RoboCup Soccer robots.
Yes, we participated last year, and because of Corona, we don't know if this takes place this year. So we decided to try this simulation competition.
Mm-hmm. So how did you find the change from RoboCup Soccer to Rescue Simulation?
It is a great difference because we started programming with Python, and my mate is not a Python programmer, so he had some problems with that.
Mm-hmm.
For me, it was fine, but I was working more alone because he was learning Python all the time.
I see. Okay. Regarding your robot and your program, do you have anything that you think you would implement differently or work on if you had some more time?
Yes, very much. I think the problem was if we drive, or if we are very close to a wall with the front sensor, the robot turns right, and we draw a map, or a robot creates a map, and if the tile in front of him is visited, or if he can't go there, he would go right or left. And if he can't visit the tile in front of him, he would go left.
But if the wall is in front of him, he turns right. So in this case, he would do nothing. And with this, we had much points in the most test worlds, but not in this world.
Right, I see.
So
yeah,
it was luck for us with the map, and we were unlucky.
I see. Okay. Do you have any questions for us or Raptor B, the other team on this call?
No.
Okay. All right. Well, thank you for coming on. And next up, we have Raptor B. Can you hear us?
Hello.
Yes, do you hear me?
Yes.
Yeah. Okay.
So we just have a few things to ask you. So congratulations on your impressive run. That was very nice.
Oh, thank you.
And so one of our questions is, how did you detect visual victims and validate the type of victim? It was very impressive how you were able to get sideways views and almost see them instantly. So.
The thing is that it doesn't check the victim in the current tile. It checks the next tile because the cameras are at the front. So I thought this would be a problem at first, but then I thought about it, and we found a strategy, and that would be to see the victims in the of the next tile. So in this way, the field of view is huge. So. Yes, it's good this way.
Yeah, we've seen them in a lot of teams very successfully do that process where they check for victims ahead of time in the previous tile. So yeah, it seems like a very solid system. And
also go ahead, sorry.
Because this is a simulation platform, I guess it helped us a lot because of the noise. Like it wasn't really a problem for us.
Yeah, I was going to ask you just to follow up on that, but how did you deal with them? So obviously, if you're looking ahead on the wall, the pictures are quite skewed. Did you try to like unskew them and then do detection?
Okay, let me explain how I thought about doing this. First, I thought about AI or something to find a letter. Then okay, that was too complicated. Then I tried making a template for the letters, so each pixel for that, and then some sort of scaling. But that also went pretty bad. That was pretty difficult. So I went with a really simple strategy to find it. And what he did was checked for the most upper left white pixel to find where the letter is.
Yeah.
And then it can find the size. With that, it traces a line in the middle of the letter, and it checks some specific points in that. And with that, we can recognize the 3 types of letters. One thing that's good is that there's only 3 letters, so this helped us a lot.
Yeah, no, that makes sense. That's really good. I really like how you try to go through different methods and went with the one that you understand the most, and it does work. And indeed, it worked very well in the run.
Yeah,
so.
It worked not so good because of that H. He missed that letter at the end.
Yeah.
Yes.
I got really mad at that, but yeah.
I also really know how sometimes the simplest solution is just the best solution.
Yeah.
Yes.
Also, as I mentioned, the simulator really helped a lot because of the noise. It's not that good, not that great. So.
To further ask some questions, what type of navigation system did you use? As we saw, it was very, very effective in finding a variety of rooms, except for maybe the end part. But
yeah. So it follows the right wall. So it has a priority for going to right, then front and left. Do that, and when it gets to a dead end, it does a BFS to the closest unvisited tile. And to make the movement more precise, it does some adjustments in the field. The problem that happened there was it recognized the wall as an obstacle, and because I guess he wasn't far too much. He walked less than it should. And so it identified that, but thankfully there was a wall at the other part at the end, and then it could make an adjustment so that nothing bad happened. It is also compromised with the BFS, and if it couldn't get there, like it wouldn't even pass there after.
Seems like it really did an amazing job on that.
Oh.
Yeah.
We have one more question for you. So, you mentioned that you participated in rescue maze before the simulation. So how did you do it? How did you enjoy each of them? How did they compare?
How did they compare? So, like, I mean, the real competition is way more challenging. Like, just to give a picture, we did all the code, or like 90% of the code in 3 days. I'm not kidding. It was crazy. Like, the deadline was like on a Friday, and we didn't have most of the program done at like Monday. So it was really, really painful, but it paid off really well.
I see.
Yes, apart from the physical part that isn't there, which makes things a lot easier. And again, mentioning the noise, for example, for sensors is quite non-existent. So
yeah,
that helps a lot.
I see.
But I really enjoyed this competition. Like, it's also good to test different kinds of algorithms if you're interested in using this with the Rio competition. So yeah, that's it.
Anyway, that's all the questions we have. Do you have any questions for us or for Tux Virtual over here?
I don't think so. Like, just like to thank you for the opportunity of the event, and that's it.
Thank you for participating.
All right. Okay, thank you very much, Tux Virtual and Raptor B, for joining this Q&A session. So I believe we have finished all of our runs, our Q&A sessions. So thank you everyone for listening and staying in. We have a final section, so we have the award ceremony and some more info about what happens after that. But before that, we're going to have a quick coffee break for 10 minutes, and we'll see everyone back 3:10. right, we're back. And so we have finished all of the runs. And finally, we will be going over the awards. So the first, second, and third place for this competition.
So in third place, we got Nisshin Yasui, who scored 270 in 8 minutes. So great job.
Congratulations. In second place, we got Raptor V with 307 points and the game time of 4 minutes 16 seconds. This is almost half the time. So impressive work and congratulations.
And in first place, we got TFA 309, who scored a perfect score of 340 in 4 minutes and 46 seconds. Very accurate and efficient. So amazing work.
All right. So that's the first, second, and third place for the competition. Congratulations again. So we'll now go through some of the kind of procedures for certificates and things like this. So all these certificates for the teams who won the awards can be accessed through the submission portal, and you can download them. But beware, there's a 2-week deadline since the server will be deleted after 2 weeks. But you can go to that portal and get your certificates.
The awards are also now online. You can get to them by clicking this link, and you can share it on your social media.
So these are all the videos from the top performing teams. They're on the website for RoboCup Junior Rescue. But also, all of the other games are online. So all the games that we just saw and commentated on are online. There's also a comment section as well. And please share it on social media so this event is known to more people.
Even if you did not place first, second, or third, you can get a certificate of participation. And like before, you can download it from the submission portal. After 2 weeks, it will be deleted from the server, so be sure to do that quickly.
Finally, we got some 2 more announcements before we finish. So the first one is the feedback form. So as mentioned, this is our first time running this kind of event, and it was really exciting to make this happen. And I hope everyone had a great time. But you'll be really thankful for us to get feedback from the teams and mentors and anyone who were involved to make a better competition for the next time. So you can access the feedback form from the submission portal, and we'll also circulate it in the various communication methods to the teams. But bear this in mind. And finally, we got an announcement as well. So this is an announcement for the RoboCup soccer simulation. So following a competition for rescue simulation, the soccer league has also started a soccer simulation league, and it's actually using the same platform, Webots. So those who participated in this competition might find it easy to transfer to this simulation as well. So if you're interested, this is happening. Check out the soccer simulation thread on the official RoboCup Junior forum, and you can ask the soccer TC and OC about how the competition is organized. But yeah, this is a thing that's going to happen for RoboCup Junior Soccer. So consider participating in this event as well. Okay, so that marks officially the end of this live event. I hope all the participants and spectators and everyone had an enjoyable time. We certainly did. It was great to see all the robots and their runs and team's efforts to solve the maze. So we hope to see some of you guys in the upcoming competition in Bordeaux. And we also don't forget to follow all the communication channels on Discord and the forum for any updates on the platform and the competition and how this league is moving forwards. All right. Thank you, everyone. And this is the end of this live event. Goodbye. See you.
Bye.